The prospect of alien life in the universe is something that has always piqued the interest of people across our planet. While we have mostly associated alien life with probably existing somewhere far away from Earth, new evidence suggests we may find it a lot closer to home than previously expected. Scientists have revealed new evidence that Jupiter's icy moon Europa may have harbored life beneath its surface. Let's talk about this new evidence and if our search for extraterrestrial life is finally coming to an end. Europa is one of the Galilean moons of Jupiter, along with Io, Ganymede, and Callisto. Astronomer Galileo Galilei gets the credit for discovering these moons, among the largest in the solar system. Europa is the smallest of the four, but it is one of the more intriguing satellites. The surface of Europa is frozen, covered with a layer of ice, but scientists think that there is an ocean beneath the surface. The icy surface also makes the moon one of the most reflective in the solar system. Researchers using the Hubble Space Telescope spotted a possible water plume jetting from Europa's south polar region in 2012. A different research team, after repeated attempts to confirm the observations, saw apparent plumes in 2014 and 2016. The researchers caution that the plumes haven't yet been fully confirmed, but they do provide a suggestion that there is water in Europa's ocean jetting to the surface. Several spacecraft have done flybys of Europa. The Galileo spacecraft did a long-term mission to Jupiter and its moons between 1995 and 2003. Both NASA and the European Space Agency plan missions to Europa and other moons that would leave Earth in the 2020s. A prominent feature of Europa is its high degree of reflectivity. Europa's icy crust gives it an albedo, or light reflectivity, of 0.64, one of the highest of all the moons in the entire solar system. Scientists estimate that Europa's surface is about 20 million to 180 million years old, which makes it fairly young. Pictures and data from the Galileo spacecraft suggest Europa is made of silicate rock and has an iron core and rocky mantle, much like Earth does. Unlike the interior of Earth, however, the rocky interior of Europa is surrounded by a layer of water or ice that is between 50 and 105 miles. Due to fluctuations in Europa's magnetic field that suggest the presence of a conductor of some sort, scientists also think that there is an ocean deep beneath the surface of the moon. This ocean could contain some form of life. This possibility of extraterrestrial life is one of the reasons interest in Europa remains high. Recent studies have given new life to the theory that Europa can support life. The surface of Europa is covered with cracks. Many believe these cracks are the result of tidal forces on the ocean beneath the surface. It's possible that, when Europa's orbit takes it close to Jupiter, the tide of the sea beneath the ice rises higher than normal. If this is so, the constant raising and lowering of the sea caused many of the cracks observed on the surface of the moon. Obtaining samples of the ocean may not require drilling through the icy crust, should the repeated observations of possible plumes turn out to be actual jets of water. While researchers spotted evidence in 2012, 2014, and 2016, the true nature of the plumes and why they appear sporadically requires more observations. In 2014, scientists found that Europa may host a form of plate tectonics. Previously, Earth was the only known body in the solar system with a dynamic crust, which is considered helpful in the evolution of life on the planet. A new model from NASA scientists supports the theory that the interior ocean in Jupiter's moon Europa would be able to sustain life. In addition, they have calculated that this water, believed to be an ocean under the surface ice shell, could have been formed by the breakdown of water-containing minerals due to either tidal forces or radioactive decay. This work, which is not yet peer-reviewed, may have implications for other moons in the solar system. Europa is one of the largest moons in the solar system. Since the flybys of the Voyager and Galileo spacecraft, scientists have held that the surface crust floats on a subsurface ocean. However, the origins and composition of this ocean have been unclear. The researchers found that ocean worlds such as Europa can be formed by metamorphism. In other words, heating and increased pressure caused by early radioactive decay or later subsurface tidal movement would cause the breakdown of water-containing minerals and the release of the trapped water. They also found that this ocean would originally have been mildly acidic with high concentrations of carbon dioxide, calcium, and sulfate. While scientists believe that this ocean could be sulfuric, simulations coupled with data from the Hubble Space Telescope shows the presence of chloride on Europa's surface, suggesting that the water is also most likely rich in chloride. This means that the composition of the water on the moon has become more like the oceans on Earth. This leads researchers to believe that this ocean could be quite habitable for life. Scientists at NASA maintain that Europa remains one of our best chances of finding life in our solar system. The agency's upcoming Europa Clipper mission will launch sometime in the next few years, and the current research on the moon aims to help prepare for this endeavor. The mission will investigate Europa's habitability, among other objectives. Current models suggest that the oceans on other moons, such as Europa's neighbor Ganymede and Saturn's moon Titan, may also have been formed by similar processes. However, several key points still need to be studied further, such as how fluids migrate through Europa's rocky interior. NASA has recently doubled down on its effort to find life in the solar system with the extension of both the Juno and InSight missions. Juno, the agency's mission to Jupiter, will now be dedicated to studying the planet's moons, including Europa. InSight, meanwhile, furthers the commitment to bring humans to Mars and perhaps further afield. Juno launched on August 5, 2011, headed toward the largest planet in the solar system. The spacecraft has been instrumental in the search for life among the other 8 planets that make up our cosmic neighborhood. The spacecraft completes one orbit around Jupiter every 53 days, collecting data on the gas giant to determine how the planet formed and evolved. The main objective of the mission so far has been to measure the composition of Jupiter's atmosphere, determine how much water is in the atmosphere, map the planet's magnetic field, and how its magnetic force affects its atmosphere. Now, Juno will explore Jupiter's rings and larger moons, and there are flybys planned for the moons Ganymede, Europa, and Io. Jupiter has 79 confirmed moons, but those 3 are by far the most special. Io is the most volcanically active body in the solar system, while Ganymede is the largest planetary satellite yet discovered in the solar system, with its massive size making it larger than the planet Mercury and about 3/4 the size of Mars. Europa, however, remains the most intriguing. Due to the potential existence of a chloride-rich ocean, the craft will extensively study the moon in an attempt to uncover more information about its habitability. Until the Europa Clipper mission launches, Juno will continue to study the moon and help scientists bridge the gap between the 2 missions. As yet, we have no evidence for life on Europa, but between 50 and 80% of life on Earth is in the ocean. Not only plants, coral, fish, and mammals, but also extremophiles, organisms that survive in extreme environments. They live in freezing realms below Arctic sea ice and the boiling temperatures and crushing pressures around deep sea hydrothermal vents. Europa also seems to have life's secret ingredient: time. Earth's oldest fossils are 3.5 billion years old. That means life got a foothold on our planet soon after conditions allowed it to survive, and Europa's ocean may have existed for billions of years. Given what we know about the ingredients for life, how quickly life sprung forth on Earth once conditions allowed it, and that life finds ways to survive in extreme environments, Europa is the premier place to seek life beyond Earth. Europa Clipper is our biggest chance of discovering life on the moon. Europa Clipper originated in a mission that was intended to include participation with the European Space Agency and the Japanese Aerospace Exploration Agency. Recently, though, NASA remains the only agency still working on the project. The current mission plans calls for Clipper to do as many as 45 flybys of Europa at different altitudes, ranging from 16 miles to 1,700 miles above the moon's surface. The flybys would make close passes of Europa and then move to a zone much farther away, where the spacecraft could transmit and receive data from Earth and be prepared for the next flyby of the icy moon. As things stand, scientists are waiting for more data that could confirm or deny the signs of life in our solar system. If you like this video, please consider watching this one, which talks about NASA and how they may have found signs of life on Saturn's moon. Do you think life exists in our solar system other than Earth? Please share your thoughts in the comments section below.